Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, I guess we'll get started. It is my pleasure today to welcome James Landay from the University of Washington. James is an associate professor there. Most of you know him very well. We've collaborated with him in the past, have his students as interns, and actually we'll be working very closely together, I hope, in the next couple of years as James puts together a HCI program, or James and his colleagues, I should say, put together an HCI program that hopefully Microsoft and Intel Research Labs will be strongly contributing to and interacting with as we move forward. James has graciously offered to come back if there's lots of interest after he talks, to meet with people in the morning of Thursday, March 1st, I think it is. So there's another opportunity to interact with him if you're out in the Netherlands, listening to this, Netherlands meaning the ether, listening to this talk and you find out you want to interact with James, we can invite him back. So with that, take it away, James.
Okay. I want to thank the small crowd for you who made it through today's ice storm to come to my talk. Appreciate the hardy folks who braved the traffic. So what I really want to talk about today is really, I think, a 5-year research agenda that maybe we're into about year 2. Mary can say she saw an early version of this 2.5 years ago, so she'll be able to say whether it looks like we did anything yet or not. Into trying to simplify our lives through what I call activity-based computing, and I'll talk about it. But this is really a large collaborative project. Started really at Intel Research Seattle, where I was the director for 3 years. So a lot of the names you see on there are folks at Intel Research that have done a lot of the work that you'll see here and are still pushing on sub-pieces of the project. And then a lot more of the future work is shifting with me as I'm now at UW full-time, mainly through graduate students and postdoc Yang Lee. And so I'll try to credit folks as I go through with who's doing what, so you know who the kind of key players are as I talk about this. So kind of one of the original motivations for the work was really kind of reactionary in some ways. It was a reaction to kind of what I saw as a lot of the other research that was going on in the ubiquitous computing community that looked to me like just creating new gadgets that will complicate people's lives. And looking out there at what was happening with this complexity. So one issue was, if you look even in current commercial products today, there was a recent study, somebody I think did it as part of their dissertation in the Netherlands, the real Netherlands I think this time, where they found that 50% of technology product returns were due to the person not being able to figure out how to use it, not that it was actually broken in any way. So people would buy stuff, typically networking stuff, get it home, and they just could not figure it out, and or get it to work with their things, and they return it, which seems like a rather high rejection rate, adds a lot of cost. Also found from a lot of informal research that a lot of people found that technology they used didn't really understand their lives and when they wanted to use it, and they tended to just turn it off at times to get it out of their life, like people turning off cell phones at home, or people making it so that their work email wouldn't work at home because it didn't kind of respect the boundaries they wanted to keep. There's a lot of underutilization going on. I'm sure a lot of you experience this in your own lives in terms of you know the potential of all the devices you might have of how they might work well together, but really you can't get them to work well together, so you're kind of not utilizing them as well as you want. So there's a lot of people that a lot of this complexity leads to underutilization, or even folks like the people who wrote this book who are just like trying to switch off technology and say this is just not worth it, and go off and live with the Amish or something like this. I would claim that a lot of trends out there in industry as well as research are actually going to make the complexity get worse, or at least if industry succeeds, it will get really worse. One is proliferation. Just starting to have hundreds, tens to hundreds of devices in your environment. So, people are kind of surprised how many computing devices they actually have when you start to think of how many things have processing in them. There's also this pervasiveness has to do with how I talked about people turning things off. There's a lot of dissolving between people's work and home life, what happens where. I'm sure a lot of people do some personal home things at work as well as the other way. And a lot of the technology we use doesn't really respect what we're doing when, because it doesn't have any idea of what activity is occurring. And then finally, I think really a trend that is really increasing complexity or has already caused it is really the dominant human-computer interaction design technique, which is essentially designing around tasks. I've been teaching it for 10 years. Many other people have. We essentially teach students to figure out in a user-centered way what are the key tasks that someone's trying to achieve and design to optimize that. Unfortunately, that's always in this kind of silo of designing one application. And in many ways, people are really engaged in higher level activities than that. And they're doing a lot of tasks. And those things need to be interweaved together better. They don't work well when you only have designed for this one task, but you haven't really paid attention to other things people are doing. And I think folks are starting to get a view of that. If you read Don Norman's written 2 articles over the last year and a half or 2 in Interactions about, essentially the danger in human-centered design, he's really getting at this task versus activity direction that you might want to look at further. So some folks have even started to think, if you heard a lot about the digital divide 2 or 3 years ago, 4 years ago, and that was mainly an economic argument saying there's going to be those of us who have technology and those who don't because they can't afford it. Well, in some ways, I think that economic argument has not really turned out to be as big. Technology prices have dropped, quite low. You can, pick up something for $300 or $400, which a lot of people, even low income, can spend on entertainment devices. So it's starting to become not so much about economics as much as about complexity. A lot of this stuff is simply too hard to use for people who don't have a lot of training in it, and they might not use it. So all of those ideas were really motivating this research project and saying, could we figure out a way to apply UbiComp in a way to try to simplify our lives, not complicate it, and at the same time pay attention to the technology that we were introducing so that it itself didn't complicate our lives. So we could do the typical thing, which is to say, oh yeah, we're going to create this new device so you can find your lost keys and your kids' lost toys. That will really simplify your life, but you're going to pay us $10,000 and you got to add these infrastructure here and there and it will work. Well, that's really going to complicate your lives. It might be easier just to kind of look around your house to find the object. So that was sort of the motivation for what we were doing. So the key research idea and the angle I took is we wanted to start to say, could we look for those high-level, long-lived activities in people's lives that they really value and try to figure out how we could build technology to support those. So that's really the kind of problems that you pick. So in some ways, this is just the philosophy of what problems you're going to work on. So these are things like staying healthy or fit. So I want to get fit. Or graceful aging. Grandma, we want her to be able to live in her home independently for an extra few years rather than have to move into some assisted living situation.
I thought you were about to talk about the high school reunion.
The high school reunion. Social awareness maybe is more the high school reunion story. How can I keep track and keep in touch with what's going on with my friends and family, those people I used to hang out with high school, to know what's going on so we stay connected so it doesn't so easily drop off. These are just examples of the type of problems that I think we want to solve instead of find my lost keys. And I think a lot of the projects that you see coming out of the ubiquitous computing community are simple things like find lost keys and not motivated on high-value problems. There's problems, though, and maybe this is the reason. There's problems with picking research problems like this. They're hard. Some of the reasons are, first of all, they're fairly high level, so they probably have to support a variety of applications and devices to actually support those activities, like staying healthy. You don't just do that in one place using one device. It's many different decisions you make in your life. They tend to be physical. So, all 3 of those problems have to do with things I do in the physical world. Graceful aging. Is grandma able to cook properly? Is she able to clean herself? Fitness. Am I, walking as much as I need to do? Am I getting to the gym and lifting weights? Am I eating better? Even social awareness. It's the social, physical things that we're doing. We're interacting, having conversations with our friends. They tend to be activities that are dynamic, meaning that they're going to change over time. Okay? So graceful aging is kind of a nice way to say grandma's capabilities are declining over time, and we're trying to support them. So it's not like we're designing for static grandma who's 84 right now, and all her capabilities are going to be the same right now in 6 months or in a year. We're going to have to make applications that are somehow going to support as her abilities and disabilities change. Similarly, if you thought about graceful learning, kids, as their abilities get better, right, they're changing dynamically. You want to be able to support something like that in education. So applications that are going to support these long-lived, high-level activities have a few, I think, key characteristics that would make them more successful. One is they need to, in some way, support and admit the social part of the application. Okay? And by this, I mean try to facilitate relationships, or at least make sure that you don't mess up relationships. So we can imagine lots of automated things we can do to kind of support things socially. But if you do those automated things and they do something stupid, like reveal some location to somebody that it's awkward for them to know you were there, you can really mess up a social situation. So we have to be careful with the social design and admit it's there. We also want to get at that, make these things simple to use. So try to take advantage of natural interactions in the physical world. So we can think of the standard natural interactions, things like speech and multimodal input are things that people have been working on for 30 years in terms of saying those could be natural. Or we can just be talking about letting people manipulate familiar everyday objects the way they think to manipulate them and take advantage of those in the user interface. And I'll give examples of that in a minute. And then finally, if we're going to support long-lived activities that occur in our everyday lives, we're going to have to support you being able to get at applications and other things that support it wherever and whenever you want. It can't be something, well, that works when you're at home and you log into your PC or on your laptop. Okay? It needs to be something that I can access all the time, always at hand off of, let's say, a mobile phone, or make it really easy to appropriate a display if we ever get to that kind of scenario where we can actually do that. I don't really care exactly which one of those it is, but I'm just saying you need to get at the stuff whenever you need it, in the real world, which means, in your car, when you're walking down the street, when you're in your office, wherever. So I want to show a short video here that was created at Intel about 2 years ago. Some of the technology you'll see in this video, like this CareNet display, came directly out of research in the Intel Research Seattle lab. Some of it is technology that are simply ideas that came out of a digital health research project that was looking at graceful aging inside of Intel, run by Eric Dishman. And this video was the first production from the new digital health product group that Intel started about 2 years ago. And it was meant as just a way to give people a vision of what they saw, the kinds of technology that would come down in the future. The reason I want to show it to you is just to show you what might be an example of supporting a high-level long-lived activity. I don't advocate all the technologies you'll see in here. Some I find actually way too intrusive, and others I like. It tends to be the ones out of my lab I like, and other ones not so much. But I think the video kind of gives you a flavor of the kind of thing that I'm talking about. So I want to just show that. So Intel's lawyers require this long legal disclaimer so that you don't suddenly start buying or selling Intel stock based on what you think from seeing this video. Amazing.
It'd be nice to have a piece of yourself.
Since my father-in-law died, my mother-in-law lives alone. She's not that far away, an hour depending on traffic.
अभी पिताजी तो मैं इंडिया से कुछ नहीं ले आई, ये थे आके स्टोर बनाया, सारी उम्र काम कीता है, हुन मेरे को नहीं हुंदा.
We visit a lot, but we can't be there all the time, We have to be here.
It's very difficult to run the store and same time take care of my mother.
It's very important to check up on grandma because she lives alone, and even though she's very independent, we still need to make sure she's taking her medications.
Some medicine 2 times a day, some with food, some with water.
Beta blockers, Vioxx, but others like Coumadin, she has to take them in a half-hour window. So it's hard to keep track for her, and even for us to remember all that. She forgets to take her medicines. Sometimes she will take the medicine twice. So I have to watch all that. हाँ जी मम्मी, क्या हाल है आपका? आपकी दवाई का टाइम हो गया है? आप इसी टाइम क्यूमेडिन ले लो.
नहीं उषा, मैं भूल गई थी दवाई लेनी. मैं जाके ले लेनी है.
हम आज शाम को आएंगे आपको मिलने और डिनर आपके साथ ही करेंगे. ठीक है? Plus she has to remember all the normal things. If she's getting enough sleep, eating enough, we have to keep track of all those things.
I can see right away if everything's okay, if she's been taking her medicine, if she's getting the proper exercise, if she's falling, does she need any help? We can get to her right away. She's got a bracelet which communicates with sensors in the house, so we can tell if she's having a good day or if she needs some help.
My mother and Hansaben have been friends for years. They like to go out for walks together. But now with this technology, my mother doesn't have to remember to call her.
When she reaches for her cane, her friend gets a call. It's pretty cool. It works the other way too. She's got a lamp at her house that goes on when we reach home, and it's comforting for her to know that we're home.
She likes to know what's going on. It helps her feel connected.
इस घर को मैं छड़ के नहीं जाना चाहती. मैंने बहुत अच्छा लगता है घर.
I love my grandma. She means the world to me, and if she needs my help, I can be there right away for her.
जिस वक्त मैं जरूरत होती है, मैं नहीं लगता मेरे बच्चे मेरे कोल ने.
With this technology, I know she is safe.
It's like being there, even when we can't be.
For me, family is everything.
So you can tell from the logo when that was made. Not professional actors, actually. That was a real family who lives in Emeryville, California, who they recruited. I thought they did really well for non-professionals. So, things like that cane I find just a little too much. But just to give you an idea, that's a scenario where you might be supporting someone's activities over a period of time and how there's several people involved. It's not like you just go sit and do some Excel in your office by yourself. It's a lot of people involved. So if you look at, what is the long-lived activity? Well, it's let mom live a healthy and independent life. And, it's physical, it's dynamic. Is it high value? Yeah, it's high value to all. It's high value to mom because her quality of life is better to live in her own home. Most people do not want to leave their homes to go into one of these facilities. It's, in fact, the step that causes many people to die soon after that. It also is high value to the family and simplifies their lives. So if you looked at the studies of what actually happens in these scenarios, is often what happens is one of the children, typically an elder daughter, tends to quit her job or take part-time work to take care of mom. They tend to not exercise, they tend to give up vacations, they tend to make all kinds of compromises for several years while they care for the elder, at first kind of part-time helping out as things decline more until they get to the point where they need to go into a care facility because it just becomes too much. So that person's life's simplified. And then, Dan.
I'm sorry. I'm not sure what you want to do about questions.
No, ask them as we go. It's fine.
Just trying to, I understand the idea here. I'm just trying to understand why you picked this problem. So I understand the attributes of the problem.
Right.
But did you pick the problem because you thought this was an incredibly challenging problem for
You mean the elder care scenario itself, or activity in general?
Either elder care or actually long-lived activities in everyday lives. Why
Right.
is that? Is that one because you thought we could make progress on it, or is that was because it's especially challenging, or because it's
I think it's especially valuable. To me, this is the place where computing has not touched our lives, not because it's valuable, because it's actually hard and challenging. So there's a lot of research problems there, but I wouldn't do them unless I thought the payoff was big. So I think problems like this, like the elder care scenario, are high payoff problems that are going to be valuable either from a societal sense of value or even from a monetary sense of saying this is a good business to be in because people will value it and pay for it. Okay? So And in fact, the elder care one, in some ways, I pick because we've already done work on it. So it lets me describe what we've done and show how we might move forward to another problem. So if we look at this actual problem, we can see in terms of the social issue, there is that entire care network of people involved. So it's not just the elder, it's the elder. Her medical team, which is not seen in the video, but you can imagine them looking at the same data in some more kind of professional system to see, is her performance, is she able to do things the same over time, is that declining? There's the family, there's friends. And you need to design for those people differently. For example, it's obvious the difference between the medical folks, but even in a deployment we did of this system, one of the elders said, my grandson is an alcoholic or had a drug problem. I don't mind him seeing my activities, but I don't want him to know about my medication. So in that situation, she needed the interface to be different for that person than a different person. And you need to be able to design and deploy a system that's going to support those kind of social differences. In terms of the natural interaction in this case, mom uses her normal utensils to cook, her pans, her pots, etc. Now, they're not so normal in the technology we use. We've tagged them with RFID tags, and I'll talk about that later. But imagine the scenarios. Use your real stuff. Maybe she wears this bracelet, or maybe we detect it in a different way, which I'll talk about. But she's using normal stuff. And that this display here, which we call the CareNet display, you put into a normal place in your house. Maybe it's on a bookshelf that has other pictures, or on the kitchen counter. And normally it looks to you like a picture of mom, and these extra icons giving you some idea of what she's done today. But when you want to find out more, you simply touch it, and you can get more information. The interaction is quite natural, quite simple. And then finally, we talked about always at hand being a key application element for these kind of long-lived, high-level activities. And so in this case, you imagine, okay, we have the picture frame, but you can also imagine accessing it on the phone. The grandson's out there, wherever he was at the bus stop going, what's going on with grandma? Or you can imagine the web browser is maybe the way the woman at work is looking at it, or the doctor. So you might say, well, what happened with this kind of technology? So we actually built this display, or I should say Sonny Consalvo and others at Intel Lab built it. And they deployed it to 4 different care networks. I think it was a total of 14 people involved. So there are 4 different elders, and then for each of them there was a different number of adult children who had the display in their homes. And it was pretty successful. Now, at that time, we didn't have any of the activity inference technology in place. So we did a Wizard of Oz methodology using the best technology that we had at hand, which was called a graduate student. And the graduate student called the elder 4 times a day and said, did you take your pills? Did you, eat lunch? Did you wash? And he put that into a database. But to the families who were at home, they simply had this display, and it seemed like the real system was working. Okay? So the results of that deployment were really interesting. People said, yeah, I would like this as a product. Now, this isn't testing any of the, wearing a bracelet and do the RFID tags and all this kind of AI and inferencing stuff work, the sensing. But in terms of the user experience for the family, it was really positive. Now, how was it positive? The first thing is, in these situations, the relationship between the elder and her family really changes. Mom suddenly gets treated like a child. Mom, did you take your pills? Mom, did you eat? And there's in some ways, a little resentment about that it's actually an uncomfortable switch. What happened in this deployment is that's not what they asked mom about. They started to lift their conversation back to the kind of previous level of what you would consider substantial conversation. Things like, hey, guess what Johnny did in school today? It was back to how it might have been before. And they only had to talk about those things when a certain exceptional condition looked like it was occurring rather than all of the time. The other positive effect was this. Typically what happens when we've seen the ethnographies of these families is this one person really takes the load of caring for mom. And the other siblings kind of maybe ignore what's going on. Maybe it's so they can sleep better at night. I'm not sure why. But they never seem to be fully conscious of how much that one person has given up their life to take care of mom. Okay? And so what happened is it actually caused the siblings to just have a better clue of all that was going on in mom's life, because it also had things about doctor's appointments and who was taking her and things like that. And so it actually improved the relationship between them. It didn't necessarily get them to change who was doing all the work, but it made them more appreciative of their sibling and what they were giving up for mom. And that was something that was really noted by those families. So it was pretty positive. And I'd say positive enough that, Intel is actually funding a long-term deployment of this kind of technology with the actual inferencing technology in a large number of homes and care facilities with the state of Washington. So it's turned into a fairly large thing that they think there's a future in products like this. And if you look at the demographics of, North America as well as Northern Europe, you have to believe that certain technologies like this are actually going to be required. We're not even going to be able to avoid it if we wanted to, simply because there's not going to be enough of us to care for the number of people who are going to need help. So there is going to be a lot of technology-based solutions. So that was just meant as an example, slide 6, to get at what I mean by high-level activity. So by high level, if you look at this hierarchy here, I might mean something like what we just saw in that video. Let mom live a healthy and independent life. That's pretty high level. We can maybe take it down a level, other things that I might consider high level activities, or simply saying something like, mom eats regularly, or mom exercises regularly. In Norman's recent article, he actually would refer to this highest level thing as maybe an activity, and maybe the next level is tasks, but the terminology varies. And then below that, we might break this up into actions like eat lunch, eat breakfast, go biking, stretch. And we get all the way level to what we call operations, which tend to be non-conscious things that you do. So, somebody just knows to get on the bike and pedal. You don't actually think about it. Now, what's interesting in this hierarchy is it's not really fixed what's conscious and non-conscious. You can imagine as someone ages, things that used to be operations might move up to being actions. As the elder gets more frail, or as someone breaks some of their limbs, they might have to actually plan and think, how am I going to get that water kettle filled and put it onto the stove and make it conscious, something that used to be unconscious. Or similarly, as children learn, for example, as I watch my son learn to ride a bike or something like this, things might be really conscious for him. He has to think about steering very consciously, but as you learn them, they might become learned things in operations. So previous kind of models of human cognition, things like GOMS and stuff, have a similar hierarchy, at least at this lower level. So this hierarchy really comes out of activity theory, which is this theory really of activity that was mainly used in education for understanding people's thinking in education, developed originally early 20th century by a cadre of Russian psychologists. And it really wasn't very well known in the West, though it was picked up by a lot of CSCW researchers in the late 80s, and mainly used as a way to, as a framework to analyze field data that they might have. Okay? Hasn't really caught on for more than that, from what I can tell, though there's a lot of recent flurry of writing of it. And one of the issues I think it actually hasn't caught on is it uses terms like activity that don't necessarily map to the exact definition that you would think if you looked up activity in the dictionary. And so people get pretty confused, and the Russian papers that are translated are pretty confusing. And I'd have to say that people in CSCW's papers are fairly confusing. So it's not really caught on. And in fact, when I was first exposed to it, when I was a professor at Berkeley, John Caney was really interested in this. I was just like, I don't understand this. This seems like a kind of theoretical hogwash, and kind of threw it aside. And I should say it was Mary's keynote talk at WIST where she said you really need to have a theory behind your work that motivated me, but it wasn't actually that. It was we were actually doing work on what we called activity inference in the lab at Intel, and at the same time I knew about this activity theory, and the two things started to collide in my head as related, and I found that they were. So in some ways, we can think of it as a conceptual framework to achieve activity-based design, but I think the thing that's new, and what I'm going to show you, is everyone who's looked at activity theory previously just thought of it as a way to look at their field data. But now I think you can look at it a way as to figure out what it is you're designing and actually build activity, smart technology into applications that actually have an understanding of activity that people are engaged in. We've seen some early work in this in terms of office work out of Tom Moran's group at IBM, and maybe even some of Eric Horowitz's work here, I think has some flavor to understanding the activity people are engaged in. And this just gives you a framework to look at it. So the traditional kind of activity theory design says you have this hierarchy of activity. That's the high level someone's engaged in. Action, you can think of the things people are actually doing day to day. And then operation are those unconscious things that you do to achieve an action. But activity theory at each level of the hierarchy actually says that the subject, this is typically the person or the user, is trying to achieve an object or create an object, but that act is actually mediated through a tool. And this little hierarchy here is what got me originally interested in, which kind of said, hey, if you know something about the tool in some ways really defines the activity in a lot of ways. And we'll see that as I show you some of the activity inference work we've done. Now, if you've known the activity theory, you know it gets a lot more complicated than this. In fact, it accounts for a whole community of people who maybe are collaborating together to reach this object. And there's rules and division of labor, et cetera. But this is kind of the stuff that you really get into the more CSCW. That's why it's interesting to them, because it actually accounts for the social aspect of achieving some kind of object. So coming at this back to the original idea of, how are we going to simplify people's lives? How are we going to support these high-level activities that happen in the physical world, that have the social? There are really some key research challenges. The first one was, well, if you're going to want to understand the physical world and the physical actions that people are engaged in, how are you going to do that? If you're going to make people write down what they're doing or fill out forms all the time saying, hey, I walked from the car to the house and I talked to Desney today and he was very argumentative and whatever. No one's going to be able to journal that stuff. So one of the keys is those things are hard to record and manage, but we could actually, if we have the technology to be able to do action inference, to be able to understand what you're actually doing, and social inference, we could build systems that actually can get that information automatically rather than have you do it manually, which is just going to fall flat. The other issue is I talked a bit about social relationships being complex and delicate. If we're going to do any of this kind of inference stuff, when we get to the social part, we need to be very careful. So if we're doing social inference, like inferring that Desi and I were having some kind of fight or whatever, we probably don't want to automatically act on that inference and instead just use that as information that the human is going to make the final decision on that. So it's just kind of saying, traditional HCI, whenever we get into intelligent systems, is keep the human in the loop. Well, that's especially important, I think, for those social aspects where messing it up could be the difference between total failure or not of the system. I talked a bit about natural interactions. Well, like I said, people have been working on it for 30 or 40 years. The problem is natural interactions like speech and gesture and multimodal stuff, it's inherently ambiguous. And so that makes the recognition challenges hard. And we've gotten a lot better, The handwriting recognition things have gotten better in tablet PC, and work things like, that Desney's done has made it easier to fix it. Multimodal's got better. But the fact is these things have always not worked well enough for a lot of people to really use them. But if we look at these kind of natural input technologies, one of the places where they seem to have worked best is where you can use domain knowledge to limit the recognition space. So if you look at, for example, all of the speech trials and things like this, places where they've done well is when you've been able to say, okay, you're working on the travel domain. Everything's about trains, planes, schedules, things like that. And so one of the ideas here is, can you use this same action inference, this understanding of the context of what we're doing in the real world, as a way to dynamically constrain these natural language recognizers, these handwriting recognizers, these multimodal recognizers, and do better on our recognition because we have a bit of clue of what you're doing instead of just trying to recognize every possibility all of the time. Similarly, you can imagine throwing other context at it, like location, etc. So it's saying do the same trick as they're doing for the travel domain, except you're changing it on the fly based on what you infer is going on. And then, to me, probably not the biggest interest from the HCI perspective, but I actually think the most probably important problem to solving this whole issue is, if we're going to say we're going to design to support people's long-lived activities, that are out there in the physical world. We need design techniques and field techniques and evaluation techniques that can be done in situ for extended periods. And unfortunately, we really don't have those techniques. We're really good now at running controlled laboratory studies. It's cookbook. We can train people. We can have huge labs like here at Microsoft. We can train undergraduates to do pretty good at it even. And you can do that. But what do you do when you say, hey, go out and find those activities in the real world that are long-lived? Well, they're long-lived, so they're going to take a while to look at. And then finally, if you build some prototype, and we say iterative design is such a great idea, iterate and try it with people, how do you run a test for months? If you look in the Chi and UbiComp literature, I think you will not find a single study in there that lasts for more than 3 months, pretty much, for at least kind of UbiComp technologies. If you look at things like web and things like where you don't actually have to deploy too much, then you might get some longer things. But Sunny Consalvo's, for her general's exam at the iSchool, did a pretty good study of that and could not find anything unless it was simple things like websites and things like that, where they really did long-term studies, because it's hard. So one way we might be able to solve that problem, though, is, again, use activity inference, location inference, social inference to be able to tag log data and let us rely on more automated methods and give us a better chance of taking those large logs and finding some real information in them when we get them back. So essentially, I've used up 40 minutes of my talk here introducing these problems. So I'm going to focus first on what is it like in terms of physical activity-based applications here and give you an example of one we're building, as well as what is the underlying technology to do that. And then I'm going to give you an idea of probably what the newest work we're working on, which is what kind of tools can we do for field work as well as for prototyping and evaluation. And I'll leave these other ones to another talk at another time. But if you have interest on what we're doing, you can ask me there. So I'll first talk about building applications. So my philosophy for this project is I had this long-term goal of where we wanted to get, and we could have worked on all those component pieces on it for a long time and then say, okay, we've got all the pieces, now let's build the app. And my problem with that is you don't know you're working on the relevant hard problems. So instead, I kind of turn it backwards and say, first you build the app, and you cut yourself in several ways and find out what's really hard about doing an app like this. And that kind of informs the tools work and the methodology work that you do. And then you probably build that app again or build another app with what you learned, and you're kind of iterating on the process. So the first app we were building is something called UbiFit, and this is an application that Sunny Consalvo, who's a student in the information school at UW, as well as one of the researchers at Intel, has been doing as part of her PhD dissertation. And so the problem is really dealing with overweight and obesity, which is a global epidemic. The numbers are right there on the slide. 1 billion people. The cost in the U.S. per year alone is over 100 billion, sorry. And, as I looked at this kind of informally, I was like, well, what's the deal? We kind of know what you need to do. In fact, there was some special pill on NPR this morning. We know what you need to do. And they all say the same thing, which is, you need to exercise more and you need to reduce your calories. But people have a hard time doing that. People are busy. For example, my wife gave me once as a Father's Day gift, I guess my son gave it to me too, but I'm not sure he was conscious of that, a personal trainer, okay? And I have this great, and if you need a personal trainer and you live over on the other side of the lake, I got the guy. This guy is good, very good. But I'd go and I'd come home 2.5 hours later and feel like, God, that was great. And my wife, who gave me the gift, after about, 10 sessions, says, you can't go to the trainer anymore. I said, what? It's really working. This guy's great. I'm getting in shape. You're gone too much. There's too much time. So if you spent the time, you can get there. But people are busy. It's hard to find the amount of time to do some of these things. So part of the idea is, can we get UbiComp technology that isn't going to get you the trainer every day, but at least gets people to make different decisions and things they do every day to kind of fit some of these things into their everyday lives, rather than say, it's all going to be at the gym. Okay? You need to exercise more, but you also could change things just every day to do better. So there's a lot of challenges with that idea, though. Fitness is one of these long-term activities. This is not something we study in the usability lab for a few hours and say, see, he can use the new life cycle, it will work, it's done. No, we got to see what happens over many months or years. And you don't work out in one place or get physical activity. You can't just say the gym. Mary does push-ups at home. It can also be, you know, in the it can be at the gym. Okay, it can be where you park your car. You know, oh yeah, I'm parking purposely in that far lot because I like to get a little extra walking in the morning. Okay, we actually, as kind of, I wouldn't call it necessarily a probe, but a first cut on this, built a system called Houston, where we had 15 women wear an Omron pedometer, which is pictured right here, which if you're looking for a pedometer, Sonny Consalvo tested about 20 pedometers and found this to be the best and most accurate, and then we read in Consumer Reports they ranked it first too. So look at Consumer Reports first sometimes and save yourself some effort. You should have seen she had like 10 on it once. So we got the Omron pedometer, a Nokia cell phone, and we had these women essentially log their pedometer count, step count, once a day. And they could also put a message like how they were feeling. And we actually had 2 groups of women, of 4 or 5, where they had a social group of other people who they were connected to, and they actually shared their step count. So they got to see their own step count as well as their friend's step count, and they had a goal step count for the week, and they could see whether they met their goal or not. And they got feedback about their goal. In fact, it was just an asterisk. And believe it or not, that asterisk was really powerful. People really appreciated the asterisk to know they hit their goal. They're like, it became the gold star, and it wasn't even gold. Okay? And there were some issues, though, that came out of that study. And these issues are kind of what are some of the key design issues that we're using as we try to build the next iteration of this. One was, you need to give people credit for everything they do. The problem is this just recorded step count. One woman said, I went bike riding 50 miles one day. And to my friends, it kind of just looked like I was being lazy because I didn't have many steps that day. Okay? Another woman said, I climbed a rock wall, you know, and I was really working out and I didn't get any credit for it. Even worse was one woman said, well, you know, I was walking up a hill in Bellevue, and my friend who was in the same group drove up, and she said, what are you doing? You don't get credit for walking up a hill. I know a good flat walk down the street. So the system even encouraged worse behavior in that case because they weren't getting credit for doing the harder thing. Okay? So it's really important to give people credit, you know, whether you can do it automatically or at least make a way to put it in. I mean, have any of you seen the Nike iPod thing you can put in your shoe and track your running? So I have one of those, and it's actually a pretty cool device. And your data gets uploaded to a Nike website, and you can set these weekly goals, and they have these great graphs. It's all very flashy. The thing that got me really frustrated is I set a goal for and it was a pretty easy goal. You know, it was like 10 runs in a month. You know, something like, I got to hit this. And I was run short. And one of those days, I forgot my iPod. Okay? And there was no way for me to self-journal it. And so I didn't hit my goal, so nobody giving me nice feedback, you know, and that thing when you get a personal best, you get Lance Armstrong comes on and says, you've met your personal best, you know. It was kind of a nice little thing, but I didn't get it. And I was kind of pissed that I couldn't do it. So you really want to try to do that. And another issue, though, is you want to motivate people without being annoying. Okay, so you don't want this nagware that says, you know, every time Dan gets to the elevator, says, Dan, take the stairs. You know, at some point that's going off into the atrium. You know, you're just throwing it. So from a user interface design, how do you make it so it's not annoying yet it's still motivating? You know, think of this as B.J. Fogg's captology. It's a persuasive interface, and it's got to be persuasive, not nagging. And then finally, we found that people really did appreciate the social support. Though you had to watch out for violating certain norms, you also had to watch out for how you set those goals. You know, they maybe should be different for different people. So setting the goals for a social group are a little more complex than just coming up with a number the way the president's, you know, Council on Fitness says. There's some subtleties to it. Yes?
You mentioned social norms. I read that this Nike iPod can be tracked by other people as well as by you to find out what
in fact, my graduate student is the one who did that work and broke it. And I can't wait to use it for something else. Though, in reality, you got to be pretty damn near the thing to track it. I actually find the whole publicity they got on it a bit overblown. It's not a very likely scenario. If it had a longer range way to track it, then yeah, but you got to be, placing a radio at the dorm and at the cafeteria in the building to track somebody. There's easier ways to track them than that. I think somebody likes to say, yeah, you can pay some Russian guy less money than, than buying that technology, and that's really the trade-off. So this is what's led to UbiFit, which is this first cross-cutting application. UbiFit stands for Ubiquitous Fitness Influencing Technologies. It uses multiple of these at-hand platforms. So it uses a mobile phone. It uses the mobile sensing platform, which is what I'm wearing right here, and I'll talk about here in a second. It could potentially use RFID or the web, though in our first iteration, those are kind of separate sub-projects that I won't talk too much about. The basic idea is, can we do automatic capture of common physical actions? So with this device that I'm wearing, we can tell whether you're walking, running, bicycling, using an elliptical trainer, sitting, okay, and a few other things like being on a Stairmaster, and it's trained by example. So if you have another physical activity that you can label examples, you could train it to do that. So the idea is you wear these and you automatically record these physical actions. Now, given that our previous study found you better give people credit for what they do, the idea was to cover more of the space with this so people get credit, but also we have a self-journaling application. So for example, if you swim, you can add that, because we weren't going to make some waterproof device, and I'm sure Josh Smith or one of my guys in the lab could have done it, but that was just beyond the research. Or if you go rock climbing, this isn't so great at picking it up, you can put it in there. So you can also self-journal. The idea of trying to be able to change people's behavior without being nagware was to try to use natural and familiar interaction. So on the phone is this small ambient garden, and essentially I'll pass around my kind of hacked up phone. It looks like I have some hot, Ken Hinckley or Andy's put some hot new technology in here, and we have a rubber band keeping it together, but that's just because my son broke my phone. But, this just kind of shows the idea is every time you take out your phone to make a call or to look at the clock, you might have seen studies that show people aren't buying watches except for expensive fashion watches because they use their cell phones. You take it out, you're getting an ambient awareness of your weekly physical activity based on the flowers you get for doing different types of physical activity over the week. And so the idea is just you get an idea how much you've done. It's also in some ways privacy preserving because Mary doesn't necessarily know what it means on my phone. It's kind of abstract.
Flowers can't be good.
Yeah, black flowers. Yeah, well, that's actually walking. We also one of my students, Kate Everett, has worked on kind of the idea of a smart gym that is doing that disambiguation of natural input based on different objects that you're using to work out, like lifting up dumbbells or using a mat or using a jump rope. She lets you log your workout manually by saying, log 20 curls, and it knows what weight and how many or something like this. And by using the context of the things you were using, we try to do better on that. There's no sensors in there. You can't, it's not an Etch-a-Sketch. It doesn't clear doing that. And then finally, we want to do in situ studies to track the long-term behavior. So this is an ongoing project, just to give you an idea. So the idea is that you should never, from a lot of literature on behavior change, you shouldn't use negative factors here. So you don't want the grass to wilt when they haven't worked out. So essentially, you start out with a nice sunny day and the grass is green. That's how your week starts. And as you do different activities, so for example, I believe this color flower is for doing cardio activities. If you do whatever the goal you set was, so typically it's 30 minutes for cardio, you get a flower. Every time you walk for 10 minutes or more, you get a sunflower. The heights don't mean anything. The positions don't mean anything. They're laid out by the algorithm just to make the display not get crowded and to look nice. There's also a different flower that you get for stretching activity and a different flower that you get for strength. Okay? So over your week, if you're doing well, your garden kind of fills, and you have a weekly goal. So for example, my weekly goal is something like 3 cardio and 7 walks. because I have a dog. So typically I'm going to get out there walking. And if you meet your weekly goal, this butterfly appears. Okay? And we're looking at kind of having a different butterfly that hangs around the next week to remember that you met your goal the last week. Because some people are saying, well, I want to, on Sunday it's something like, hey, you're bad again. They want to kind of remember that they did well. So we're looking at that. So what did we do with this design? First of all, we had a few different design ideas for this display. And Sunny ran a 75 participant survey where people kind of commented on the different designs and what they thought about them, as well as finding out about their cell phone usage and whether they ever shared their phone and what they would think about someone seeing their fitness workout and things like this. So we used that survey to kind of refine some of these ideas. The application has been implemented with both the self-journaling and the activity inference from this feeding into it. So if I show you my journal, it will actually show you the more detailed numbers for today. And I think we looked at it earlier. It said I had cycled for, 15 minutes or something. Mine has a small bug right now where every time I walk it says cycling, but that's supposed to be fixed this week. It's really great at telling me that I have been sedentary. And as a computer scientist, you get a lot of minutes for sedentary sitting in an office. The plan is to do a 3-week pilot test with about 10 to 15 people in March. That's mainly to shake out a lot of the technology. I mean, we've done it with ourselves for months, but really, can real people, for example, keep this thing running for a day, charge it, turn it on and off, which is actually one of the hard things in my opinion. It's like a cell phone. You got to hold it the right amount of time. Will they remember to self-journal things when they need to? Will the activity inference be accurate of what they actually did that day? So we have them doing some journaling and validating to make sure that see how good the data is. But the real goal for me, from the research perspective of activity-based computing is, okay, can we build a thing and really do a longer-term study? And here we're going to do a 3-month study, which you might say, especially any medical. Are there any real doctors in the crowd? Okay, just us pretend doctors. The medical people would say, 3 months, that's not long-term at all. You're not going to see any behavior change unless you have at least a year. But as I said, for the HCI field, for a physical thing like this, 3 months is quite a bit. And I'm expecting to have a lot of pain just doing 3 months. And so I want to find out what is hard about this so we can start to build tools that will make this become easier and easier. So we start to think, no, not 3 months, we're going to do 6. Yeah.
Still struggling with the main concept. So
of this
the
actual app or the whole thing?
So just training theory, I guess. It turns out that many of these systems will make you aware of an activity which you inherently don't quite enjoy, right? I remember I learned skiing in the 70s, and it was terrible. I mean, it was all like, you need to put your weight on here, and it made you completely self-focused. And later on, there were lots of papers in training theory that showed that it's actually really counterproductive to make people aware of themselves and to get better training results by focusing their attention on the environment and how they impact the environment and what they do. So I'm not sure how that's with walking, because with walking you don't necessarily, you're not really impacting anything. I remember, I've been a karate trainer for like 4 or 5 years or so, and I would kind of change my training based on that, and I would basically, instead of saying like in the beginning, would do things like, well, when you kick this, make sure that your hip goes forward that moment. None of this really works because people just can't, it really takes focus away. And later on I would just say, like, here's a big map, poke a hole as deep as you can into it. And interestingly, a lot of the things, they would basically feel certain things and, how they impact the environment. Right. And that actually gave them good feedback, and it would only shape them in right ways. So I don't know how to apply that to, like, aerobic exercises, but I'm wondering if there's a way, rather than, like, basically what they hate about walking is the act of walking. What they like about walking is the fact of having
the way it makes you feel.
Yeah. So well, I'm wondering if there's.
So I don't know enough about that theory to comment on it, and I think it's a good point, and I encourage you to take it up with Sunny, because she maybe knows that literature or maybe needs to see it. But I do know the literature that she's looked at, that a big problem is people are not aware of what they actually do, and by giving them more self-awareness, they might be able to change behavior. That the first step is simply even understanding what you're doing. People don't know in terms of this physical. Like if you ask people, the common thing I've seen is when I wear those pedometers and I sit next to somebody on a plane, and we start talking, and what do you do? Blah blah blah. And they say, oh, when I travel, I walk so much. I said, no. I said, trust me, even if you avoid those moving stairways, the days you travel across the country, you're lucky to get 1,500 steps. You're working hard to get steps. So people have a really bad sense, at least for these activities that they're doing kind of casually. I think probably you know better that, yeah, I did go to the gym 3 days, things where it's more of a planned activity, but at least for the casual things like walking and things like that, people don't have a good sense of it. So the first step for this is really to see, can this make people more aware, and can we compare to their self-journaling and see, if there's a difference between those things. But I don't know about the technical, like seeing the thing you're talking about, does it have to do with this technical skill that you're trying to teach versus just, do they make it, to karate to get there at all?
See, that's what you said, like, since you're excluding the gym, right? In the gym scenario, it's easy. So my mom, actually, I'm super proud of her. She started going to a gym at age like 65 or so. And I remember, like, it's, like after a couple of weeks, she said, like, oh, my arms feel different. And like, yes, great. Because if you reach that age, this is really like, this extends your life significantly. Like, this keeps a lot of trouble away. And so I went with her one day. I was surprised. She lifts weights, like, and so it's interesting. So instead of like thinking of how much have I pushed, right? She just looks at her body and sees, things are changed in a good way. In many ways, this seems to be the thing that you want to draw attention to, because that's actually the nice outcome, while the act of working out itself, many people perceive as kind of non-enjoyable and painful.
So I don't know if this is going to work. It's part of the research. And part of my interest is, well, I would like it to work because I think that's something I'd like. But more my interest is, can you support such an application? And if it does show an effect, that starts to show, can you do value? It could be there's some other UI that's the better UI, but you got to do it to figure it out, is kind of what I would say.
I was just going to comment kind of on that. I think that you're sort of pointing at two different things here. Like I think you pointed out, walking is one of those things where a lot of people have no idea how much they walk, and that's partly why these pedometer type things work really well. And showing that, if that's part of your goal, it's so integral to your life, and you make that part of that, you raise awareness of that, and that's an interesting impact that really is sort of orthogonal to this issue of more serious training.
Yeah.
If you're really doing training, then that's a different kind of thing. And if you're like trying to train for a marathon, etc., then you've got a really different mindset than just general awareness of how active you are.
Yeah, I would also say that earlier study we did, people really appreciated this better awareness of what they were doing, and it encouraged them to do more. But we just can't go on that from the short-term nature of the study, and we won't be able to make that kind of conclusion with the 3-week study. And in fact, medically, we won't be able to make even a behavioral change claim if it happens in the 3-month study, but you'll be able to make claims about people, essentially trying to change behavior. You won't know if it's stuck necessarily. But again, if we solve the technical problems, the future version would probably be, okay, let's add the social piece back to it, which is not in this one because we wanted to cut a variable to just focus, a bit and make it doable, and then, add pieces back and go longer term at the same time. Yeah.
So how do you think the fascination with the fact that this is new technology might make people interested to be aware for, let's say, a month, and then kind of get bored of looking at their
I think totally.
Like it's
exactly
for a really long time.
Totally, and that's exactly why you need to do the long-term studies. That's why the existing methodologies don't work and can't solve this kind of problem. That's why we need to get to the point where 3 months would be considered, your short pilot study, and we'd be able to run the longer-term study. But we want to do it in a way that we don't have to have somebody like Mary Sawinski spending her whole day for 3 months running this study. And to do these studies today actually requires that kind of manpower, including, probably some technical people too, to just keep the systems running. So, we need to get to a point where you could just let this thing go, get a bunch of data, and when it's done, analyze it and see what happened.
You had mentioned how if you, then in looking at some of the literature, it's not good to show anything negative. And I'm just sort of wondering if you're perhaps letting go of an interesting research question, because I'm imagining myself using this, and I know that actually seeing something negative, like if it starts raining and alerts me to the fact that, maybe, I need to walk more or run more or whatever, that could motivate me. Or if there's some social element where, say, my wife has some access to whatever screen.
And she
that
kicks your ass a little.
Exactly.
I mean, in some ways, the social one had a slight negative bent to it in that you didn't want the other people to see that, you didn't meet your goal a lot. So I'm not saying there's no negative in this kind of design, but a lot of the behavioral change literature Sunny has seen says having negative factors are a bad thing. So, for example, there was a thing that
or anything like that?
I cannot answer that. But there was a paper at UbiComp where they had these fish, and like the fish die if you don't keep them going, and there's some problems with that. On the other hand, I'm not saying that this is the be-all, end-all interface. So it's a research project. We got to pick one. A bunch of guys want these kind of NASCAR things that go around a track, and they get more decals on them as they go. We had to pick one, run the research. If this was a product, there'd probably be 10 versions of the screen, and you'll pick the one that's for you. And you're more like me. I probably want the more competitive version, kick my ass. And a lot of the people we interviewed kind of prefer the more beautiful flower version. I kind of, when we started the research, said, I don't want this flower thing on my phone. Come on. In fact, where is my phone? But, actually over time, I've kind of come to actually like this. I actually find it aesthetically pleasing and like having it on my phone. So it hasn't been a problem.
So part of your goal is to engender behavioral change, right? So get people to walk more by making them more aware of how far they're walking.
Sure.
Do you measure how often they check their display? Because the less often they check the display, and it still achieves the same amount of walking, that means you're making...
So there isn't really an easy way to check how much they just pull it out and look at it. But one of the other tools that I'm going to show you, I should get onto it so we get to see it, actually lets you easily log any events that people do on these Windows Mobile 5 platform phones. Was there another quick question here?
Displays go dark after a while, so you can certainly check when they light up.
So it does go dark, so we can check if you hit the button to make it light up. We probably can catch that event, though some of this low-level event programming on this is not as easy as you would like.
Just knowing the stuff's being recorded affects your behavior without checking it.
Yeah. The whole thing is affected by that. So let me skip on to the next part of the talk, which is, okay, there's an example of one application that we're actually building that is trying to pay attention to physical activity over a long period of time to affect behavior change. You might say, okay, you skip the whole part. How do you tell what activity people are engaged in? Okay, and I'm going to talk about two different types of activities. The first type is not so good for the fitness scenario, but is better for that elder care scenario that we saw in the video. And the real kind of key to this is if you saw that activity theory, it said essentially people try to achieve objects, but they are mediated by tools. One of the key insights that Matai Philippos in the Intel lab originally had was if you know what tools someone is using, you can do pretty well at inferring what physical activity they're engaged in. Okay? So in fact, these two tools that I have right now probably tell you I'm giving them a talk. Okay? The fact that grandma is using a spoon and she's touched a jar of tomato sauce and she has touched a pot and put some water in it and she's maybe touched some spaghetti or not might tell you she's making some pasta. Okay? So if you look at these are images from old Invisible Man movies, or actually an 80s remake of old Invisible Man movies. And kind of the key thing to understand is here in the bathroom you see a toothbrush moving around. And you don't see a guy there. You immediately know somebody's brushing their teeth. Now, there's some weird Invisible Man physics of there's like some toothpaste there, and maybe if you swallow it, it disappears. I don't know what, I don't think they've written the Invisible Man physics books like they have for Star Trek and things like this. And here, if you see a phone off the hook, somebody's on the phone making a call. I had to explain to students in my undergrad class the other day that that's a telephone. I said, in case you haven't seen one of these things before, and I actually need to get one of these for the next ice storm since all my phones seem to require power. I'm sure Desney's prepared. He's got one, right? No? You don't have a phone that doesn't require power? Wow. I thought you were the prepared guy taking off to Canada the second the storms hit. Okay, so what's the traditional way to solve this problem? Well, this is a problem that's been, again, people have been working on it in computer science for 30 or 40 years. We point a camera at the scene, we, as a function of the lighting conditions, the type of objects we're trying to detect, other possible signatures of the object, we pop out some object ID. Okay? Computer vision has gotten so much better. I mean, in the last 10 years, the progress those folks have made is incredible. People here, especially a lot of people at Carnegie Mellon and robotics, really great. But the fact still is, you change the colors, you change the light, you just change a few things, and the shit breaks. It's brittle. So if we're researchers doing the typical computer science thing, we want to play the future, which is, okay, let's say the computer vision guys have this major breakthrough and the stuff works. Can we just skip that part? Or is there an alternative technology? So again, the insight that Matai, along with Ken Fishkin, who used to be at the lab, had was, hey, RFID, it's becoming really cheap. It may become ubiquitous. It may replace barcodes and just be in everyday objects. It certainly will be cheap enough for certain scenarios like the elder care that you can imagine going to the elder care shop and buying all of the new pots and pans that have RFID tags built into them because it's worth it to leave grandma in her home for a couple years. Okay? I mean, these tags are down to about 2 cents, 1 cent without the packaging, and then they get sold to people who package them and mark them up. But the prices is just, it can be built into objects, not a problem. So the idea is, if grandma wore some kind of bracelet, and again, this is a research prototype that we built in the lab. This was based originally on a small RFID reader glove that Gaetano Borriello led the development of with Adam Ray, the hardware engineer at Intel. But eventually we did more industrial design, put it into a bracelet, and you can imagine it eventually being something a lot more aesthetic if you were going to throw resources at it. But using that, you can sense what objects people are touching, in what order, and what time. And then if you have models of what kind of objects are essentially used to perform certain activities, you can start to infer those activities. And there's a whole slew of AAAI HCI papers about how to automatically extract those models from knowledge on the web. So these guys have built 20,000 models automatically that in the old days we'd probably say, hey, here's the guy here, you get a PhD because you built 5 really good models by hand and you can recognize these activities. These guys have figured out how to essentially bootstrap it by doing it on the web because you don't get as good models, but then you could essentially do some learning starting with those models to make it better. So that's what they've done. Now, some people, the last time I gave this talk, said, my grandma is one of these people, and she is not going to wear a bracelet. No way. She won't even wear that one that, does medical alert if she's fallen and can't get up. So what are you going to do? So Josh Smith had the idea of simply making a new kind of RFID tag. He took 2 RFID tags, got rid of one of the antenna, and essentially put a switch, a mercury switch, between the antenna and the 2 tags. So essentially, when the tag's in this orientation, the mercury switch has made it so only RFID tag 1 is connected to the antenna. And if it changes to this orientation, you get the opposite. RFID tag 2 is attached to it. So essentially, as this object's moving around, it's kind of switching which ID it gives off. And so you could have a long-range reader that's just, hey, whenever I see ID 1 and 2 moving like that, I know that object's being manipulated. And if I only see RD1 or ID2 by themselves, it means the object's not being manipulated.
How small can you make a mercury switch?
So in this case, you can't make it that small. But you could make a MEMS switch or some other switch. And in fact, that was one of the projects that Josh was doing with folks here, just to see if we could fabricate a MEMS switch, because then you could do the whole thing in silicon and make it tiny, right? I don't know if they ever got the MEMS switch to work. Working with MEMS is actually hard. But it's certainly possible. People make MEMS accelerometers. So you could just, throw one of those. We were trying to make something even more simplistic. So this is kind of what that tag looks like. So this was the standard size for that RFID tag. And the only difference is there's these 2 tiny cans sitting out there. So this isn't going to be good for most everyday activities, but it was just to show the potential that you could make an RFID tag that kind of has some smarts to it. And Josh really went on to make later WISP chips that actually can do computation sensing, other kind of sensors, and communication, all off scavenged power. So the key of this is there's no power, and these things he's built can do a lot more. You need to fabricate them in a process and build real chips, which we haven't done. But
just like this random idea, like this will only respond if you really turn it upside down, right? But if you put in if you can make the mercury switches really small, you can actually have a whole sequence of them that respond to different angles. But then if you connect them in a way, you can still connect them in a way that either one.
So it doesn't have to turn upside down. I mean, the mercury switch, but it just depends how you align it when you tag the object, right?
How you align it?
Yeah. So if the normal way, let's say, well, you see in the video a cup. If the normal way of the holding the cup's here, yeah, you're right. If I put the switch, exactly horizontal, yeah, you got to turn it upside down. But if I put it at an angle, maybe I only need a little angle.
Well, I think for a fork or a knife or something, right?
Yeah.
But I mean, what I'm trying to say is the trick is you can always get away. I just realized you can always get away with 2 RFID tags if you use the right electronics, right? You just need a whole bunch of switches.
So
they just basically whenever they change an angle a little bit, then.
Well, what you really want to do is you just want to put an accelerometer in it. and then you're done. And essentially, this was just a cheap hack to show the viability of the technique, with off-the-shelf stuff that you could do yourself in solder without having to, spin a chip. Essentially, you want to put an accelerometer, and you can get it. So that's what we did. But just to show you, here's Josh, 2 cups, green cup, white cup, and he went to the media lab, so he has nice sounds. And it's just showing kind of that he's detecting. They're both present there in the video. They both say white cup present, green cup present, and then as he picks them up and shakes them a little, that moves. Yeah.
RFID's 2 main selling points are cheap and doesn't need battery.
All right.
Now, when it's time you're adding mercury switches and God knows what,
right,
the prices of the switches, and if you're talking grandma, somebody can see her every 2 days and stick a new battery in, and then.
No, there's no power here.
But you can put a battery. If you have a visitor, you can put a battery in.
Oh, no. If I have hundreds of objects, you will be changing batteries all the time. And that's the vision. In fact, that's the problem with all the sensor network research that's done with motes. They have this real kind of incredible vision of battery technology. And the fact is that anyone who's done any of those deployments, you're changing batteries all the time because you have these hundreds of objects. One of those batteries is always going to be failing. So this is totally powered by the reader. And again, you're not going to use mercury switches. The real thing, you've built a new chip. It has an accelerometer in it. In fact, we've built one with light sensors, other things. You have an accelerometer in it. We've built a 3D access one, but again with discrete parts, not turning a chip. But you would turn a piece of silicon, and so it would be as small as a normal RFID tag, or embedded in the actual object is what many of these things will be. So early trials for doing kind of activity inference of these physical activities, for example, an elder cleaning themselves, an elder cooking, all of the list of activities of daily living that are actually used by the healthcare industry to do elder care, we get about 85% accuracy. And that was in kind of more of a controlled study where people came into a house. They were not elders. They were able-bodied people, and they were given a task to do and to label it for ground truth. And then we saw how well the system did it. But the 2 or 3 years of hard work on the inference and stuff has led, as I said, to funding for a large in-facility trial with major health care providers in jointly sponsored by the state of Washington. That's going to happen at the end of 2007. So they're going to go to the field in something like 10 homes and 10 care facility places, or 10 rooms in care facility places, and show that it works in both of those 2 situations. So really do a larger field trial to show the validity of this kind of technology. And I suspect they will run into some major technical problems that they'll have to solve. Again, you got to do it real before you really discover some of these issues. So now I wanted to talk about is how do you sense the physical activity where you're not using a tool? So for that fitness application on the phone, how do you know that I walked? How do you know that I went running, et cetera? I'm not using a tool unless my running shoes are the tool or something like that. So how do you tell? So we want to track all of these types of activities. So this was a collaboration, again, between Intel and UW. Tanzim Chowdhury at the Intel lab did most of the machine learning, and Gaetano Borriello and his student at UW, as well as the hardware engineer at Intel, did a lot of the hardware. So they built this 2-sided sensor board that you see here. I keep forgetting. Use the green light, Luke. And it has all these sensors: 3D acceleration, digital compass, 2 kinds of audio, pressure, temperature, 3 kinds of light. In reality, for a lot of these activities, you probably just need the accelerometer. Maybe the pressure helps you know about things like going upstairs and in elevators. But this was a research platform to say, what if we have all these sensors, throw the machine learning at it, tell us what the best algorithm is. We took this a little further. Their initial work, they pretty much built a package where they then did server-side machine inference to show how well they did. But we really wanted a mobile solution where you could actually get inference in real time. So, we got some industrial designers at Intel who helped us make a nicer case, added some more storage. It's got Bluetooth, and it has an embedded processor in here, which is an X-scale processor, so think strong arm. It can pretty much run for about a day. You're looking at something like 12 to 16 hours, depending on how much stuff you're doing in terms of storage. So just about where we need it so that the person can wear it during their day and at night plug it in to recharge it for the next day. And our results aren't totally final here because we're still trying to take the AI work and make it real, make it really work on the embedded processor. And we're looking at about 75 to 90% accuracy detecting those activities. Okay, so that's where that work is. We've built about 50 of them. Now, as I said earlier, one of the key goals was to build that UbiFit application so that we could discover the research problems. So that we just didn't build all this infrastructure and then say, okay, now we're ready to build an app. Well, one of the research problems that we ran into was making that machine learning stuff work for real in a real application is harder than just reading the AI papers and implementing the algorithms that these guys had and where they showed the stuff worked on kind of more controlled situations, offline. So one of the issues is, for example, my thing says I'm cycling, not walking. How can we get better or what I would call good out-of-the-box inference engines? So how do we make it easier just for people to label examples and to manage sets of examples, who they came from, when they were doing it, just some software to make that process easier. It's very ad hoc, and we found that messed things up quite a bit because, what do you know, we had too many examples from Land A, actually, that dominated all the data at one point. It worked really well for me at the start because I had a lot of data. So you actually need an infrastructure just to keep track of who you have and what they were doing and when so that you can start to say, oh, we have too much of that data, let's throw some of it out. You need visualization tools because you start to have, in these kind of systems, hundreds of features that you're learning on. In fact, I think in the paper we had 590 something. And we had 10 sensors. And you want to start saying, hey, that's kind of weird. It seems to be inferring whether you're bicycling based on temperature. It doesn't probably make sense. Can we turn that feature off for this, that sensor off for this activity, and make that really easy to do and relearn the thing and see how well it does? Again, the tools aren't very good. And then finally, you want nice applications to make it really easy for people to see, oh, it thinks I'm cycling right now. No. And relearn and get the system to train better. So that would just be trying to make out-of-the-box inference better for the users we deploy something for. The next step is kind of how do you lower the cost to get really great inference? To get really great inference, you probably have to make the system more specialized to individual users. So just kind of like how speech systems previously were, you need to do some training to make it work well for you, but people don't really like to do training. So, how could you have that good out-of-the-box inference, but also ask people questions at very opportune times from both the perspective of the machine learning as well as from the user? What are the best times to ask them a question to really make the inference get a lot better? Like, are you walking right now? Well, you don't want to just kind of randomly ask that. You want to ask when that answer to that question would really improve your inference and hopefully not be too, again, bothering the person all the time. And then finally, to me, the good HCI question, which no one seems to know the answer to, and which I was surprised originally when I posed this 3 years ago. Nobody wants to touch it. Now they seem more interested, which is, well, what are good recognition rate? What recognition rate do you need for UbiFit? Is 80% good? 90? 75? Nobody knows. And nobody's sure about what's the exact methodology to find that out so that it's not like you're running a big study for everything you build just to figure out kind of are we good enough. So we need a little better knowledge kind of how to answer this question. I thought it was a good question, and maybe people were scared because it was too nasty and hard to come up with. But that's really important for me from a design perspective to say, if I were to give the requirements to the machine learning guy, I don't know what requirement I'm supposed to give him. He worries like, yeah, it's got to be good. They don't know what that means, 90%. So Beverly Harrison is now leading a project at Intel that's trying to get at some of these questions, along with one of my students, Kair, who's really interested in kind of this whole visualization and learning tools, how to really give you a nice tool set to look at machine learning and not have to be a machine learning expert, and just understand what experiments you've already run, what results you got, and what you want to try next. The tools for that really aren't out there, and just better tools could help people make better recognizers right now. So the other part I'm going to talk about in my remaining 5 minutes is kind of the study tools. So how can we start to study these things in situ? How can we start to prototype them and get better data? So there's really two problems that you have here in study design. And I really like the way my former student Jason Hong puts this. You want to build the right application. That means you want to find out, for this case, what activities and practices should you design for. And then you want to build the app right. That's kind of a lot of the traditional HCI or even quality control is kind of, did we actually meet our goals? So unfortunately, in the first case, it just going to take too much labor to go out there in the field and get the data that you need to find out what the right application is for a long-term activity. So we tend to just guess, going, yeah, elder care, yeah, a lot of money there, it's good, it's a long-term problem, or fitness. But trying to really understand those things right, you do a lot of field work, a lot of ethnography. It's expensive to have people for 6 months studying these kind of things. And in terms of building the app right, there's only a few people in this room who could probably go prototype one of these activity-aware applications and test it, because you need this machine learning guy, you need this hardware guy, you need these software people. It's very similar to where user interfaces were in the early 80s. There was no toolkit. You had this graphics guy who was going to create the windowing system, all the stuff you needed. So we want to kind of up-level some of this so that more creative folks can be looking at this space. So some of the challenges, how are you going to collect all this data over extended periods? If you do automated things with logs, you're going to have so much data over extended periods. How are you going to discover anything interesting in them? Anyone who's ever looked at voluminous web logs, is just like, wow, what am I going to do with all this? And then finally, from the design perspective, how do you start to figure out what those activities are and what context they occur in that are going to be of interest to design for? And then how do you design, prototype those, and test them in those contexts? So those are the problems we get at. And again, the solution is, can we actually take some of our UbiCamp technology and apply it to this problem? So can we apply it to study tools and user tools? And the key idea is for especially these study tools is, can you improve the ratio of quality to effort? And one idea is you want to use your sensing, be able to capture things like location, activity, and social inference, and tag your data with that, and then use that to make it easier and analyze the data. And you want to do it for long periods. So to give you an idea, from the user study tool perspective, we wanted to augment formative, summative study techniques like experience sampling. How many people here are familiar with experience sampling? Okay, so essentially like diary studies, something goes off, we want to ask someone a question. That's the traditional way of doing it. People have made it work on PDAs and phones. And what we can do now, though, is instead of just randomly asking you questions, we can ask you a question based on your location. So we want to do a study on, let's say, eating behavior. We can ask you a question every time you walk out of a restaurant. What did you eat? Andy, did you get the extra deluxe or did you get the light version? We could, instead of asking you these random questions, we can make it relevant. Or we can ask you questions based on activity. Okay, you just walked for 10 minutes. Was that, to get to a meeting, get to your car? We can start to ask questions that are situated almost as if we had, a field person there who asks the question based on the context. Okay, so in that case, I believe what that does is ESM essentially is high effort in terms of the user who gets asked questions. We can lower their effort by asking them questions that are more relevant and less often. Similarly, we can do logging tools where we log all of these events occurring. So think more for kind of summative evaluation. I log your use of this device like we talked about. But I also add to it context to that log. So I know what you were using when, but I also know, were you walking, were you on a bus, what was your location, etc. I might start to notice, hey, this interface seems to work fine, but whenever you're walking, it doesn't work too well. Oh, maybe there's some kind of input issue we need to look at. Okay, so instead of running a user's test for every possible scenario, we can focus in and say, hey, let's run a traditional user study where we're actually there watching someone with, let's say, mobile input. So we take that big data log, start to find where the problems are, and focus in on them. We did similar tools like this when we were doing web logging and essentially doing automated online tools, and then you do traditional usability on the places that you see problems. You can similarly do anomaly detection and other statistical techniques on these log files. That is something I'd like to look at. And then I'm just going to close with what we're doing on the design tool aspect. So one is, if you gave people these kind of sensors and let's say the phone, you could actually do field work where you're collecting context about people's activities, and you could do ESM and ask questions about what they're doing. And the idea is, well, given all that data, then how do you start to understand what's interesting? So one of the tools that we're building with Yong Lee, who's a postdoc at UW, is called Activity Prism, and it's supposed to help you kind of figure out what the interesting stakeholders, the relationships, the activities from all of that field data. So it's a tool to kind of help you analyze the field data you might collect. It's a hard problem. I don't think we have the answer yet. The one we've gotten a lot further on, though, is once you have an idea of what those interesting activities are and scenarios, can you start to design activity-based applications without being an AI expert, without being a device expert, storyboard them and test them. And so, the ESM tool looks like this. You can essentially capture audio, video. You can upload the data in real time to a database. So if you want to make sure your participants are actually doing what they're supposed to be doing, you can analyze them. And if somebody's device broke, you can really tell really quickly rather than waiting 3 weeks before they come back. You can trigger these questionnaires based on any of these sensors, like somebody went running, or you can trigger it based on virtual sensors, like activities that people use on the phone. So I can say, oh, every time you use the calendar, give them a survey to ask, something about it. Or every time they make a phone call, I could ask them a question afterwards. Every time they do an SMS, you can ask a question, or you can simply log that data and, add the context to it and use the logging later. So this has been released, and as I said, which is probably useful to you guys, it runs on Windows Mobile 5. It's called My Experience. And this is John Freilich, who's a graduate student working with me at UW, and Mike Chen at Intel. And then the last thing I was going to show you is essentially the Activity Designer is this informal prototyping tool for activity-based UIs. The whole idea is that you try to create these high-level activity-based scenes, which are essentially actions that people are carrying out in particular contexts or situations. So, for example, running in the park at lunch. And that data is going to come probably from your field work where you've used other tools to collect it. And then you can visually create status properties and visual feedback. For example, I want to notice the number of times someone ran and give them a flower for it. I can do that in this tool. And then you can use those scenes that you defined and those properties as conditions for storyboard transitions. So, and this is all done Wizard of Oz or in the field, and you don't need to program. So I'm going to skip the video because I think it's too long at this point and just show you what it looks like. So essentially, you've captured these scenes here of your field work. So things like, here's a walking workout in the park with a friend, and here's a biking workout road and a friend. And you might have media behind them, like still images that you captured from field work, or video, or just no media, or just notes can all be in here. And you can actually use these different situations or conditions to actually change these storyboards. So this is a storyboard of this fish display that was shown at UbiComp. We were just showing we can recreate their user interface without programming, all in this tool, and show that every time somebody went biking, we can kind of give them a fish. And so this is kind of a visual language for doing it. This is just to show, for example, if you wanted to count every time somebody went running, give them the fish, you kind of just create the storyboard and you have a little loop here. So they get a fish, and this shows you how it will change over time. Every time they run, they get another fish. You can either use the visual display or you can use numbers. So if you have like a display where you're going to say how many workouts, like the drill down on my phone, on the background screen, it just shows a picture. But I can drill down to the journal and see actual minutes. You could build this in here. And then finally, the idea is that you're building multiple prototypes at once. So in this tool, here's the fish display, and you get the fish for the number of workouts. And you can see the details screen, which would give you the numerical things. At the same time, you created the phone version in the same tool, and they're all together. This gets back to the activity, trying to say, it's not just going to run on the desktop. It's in these different places, and you design them together based on the same data. And then finally, here's the iPod that changes music based on the activity you're engaged in. You design all of these things, and you can use the simulator here, which automatically knows all the activities that you might want to simulate based on what you used in your design. And so you can actually test it. And this timeline lets you speed up time over weeks or days and compress it, as well as when you deploy these things for real. So these things can be tested in this tool, or they can be tested and deployed on these real devices. And the data can all be brought back into this tool and replayed in this. So you can start to say, okay, we deployed it for 3 weeks. I'm going to watch those 3 weeks over 1 hour so I can compress time down and see what was happening in these interfaces. So this is just to show you. Yang actually built this interface in the tool and deployed it for like 2 weeks with 2 different individuals, and they used it kind of to track their daily exercise. And it's not to say that this fish display is the right way to change it. We just wanted to show, here's an example of what other people have created in the literature. You could create this all in this tool without programming by someone who is simply a designer and doesn't have a formal programming background. The current version of the tool also allows scripting for people who really want to add code to do more complex things. But that's all in the tool. And so just to summarize, the whole goal of this project is to try to simplify our lives using high-level activity as kind of the organizing focus of the types of problems we work on, as well as an actual computational thing that we can create right inside of our applications. And we want to solve the problem simply, again, by using inference of activities, locations, which I didn't talk about too much here today, but we've got a lot of technology to figure out people's locations based on Wi-Fi and GSM, and then social context, which I didn't talk about too much, but Tanzim Chowdhury in the Intel Lab's done a lot of work where she can tell who you're interacting with socially, or at least how you're interacting, and you can imagine using that. And then from a tools perspective, we're making tools for design, as well as studies that leverage this tagged in situ context. And then finally, natural UIs, I only mentioned briefly, we're trying to improve the recognition using the same activity, location, social context.
Who's doing that one?
So this one, Kate Everett has been working on kind of the first example of it with this smart gym. And the work's been slower than expected just because getting the recognizers like Microsoft Speech and SAPI to actually be deterministic has been problematic. So we might look at a new recognizer to see if we can do better on that. So I don't know if that will work yet, but that's Kate who's doing that right now.
We should wrap it up there because I know we've gone over some of those in 5 o'clock meetings. So thank you.
Okay, thanks. And I should just add, I can stay around for a few minutes, but I will be back on that Thursday, March 1st. If people want to talk further, I'll be here 9 to 1:30. Desney owns the schedule. Thanks.